Hello viewers, welcome to Quick Coder. My name is Tulasi. Today's topic is Seive of Eratosthenes. Okay, so let's get started. Okay, so today's topic is something like Seive of Eratosthenes. Okay, and usually in the Seive of Eratosthenes, what we will do is, if some number is given, then we can able to find out the prime numbers up to that number. Okay, so what are the prime numbers up to 10, 2, 3, 5, 7. Okay, so this algorithm is not belongs to Save of Eratosthenes, but we usually find the prime numbers like this. Okay, what we will do is we will run a loop from I to I is equal to 2 to n because 0 and 1 are already not the prime numbers. So I will run loop from 2 to n and I always take c as 0. Then I will run for loop from j is equal to 1, j less than or equal to I, j plus plus. What happens if my I is 4, then my j loop will runs from 1, 2, 3, 4 up to 1 to this I. Then what I always do is I will do 4 modulo division 1, again 4 modulo division 2, again 4 modulo division 3, again 4 modulo division 4. So this 4 modulo division will gives me 0. This also will gives me 0. This will not gives me 0. This also gives me 0. So how many we got? So 3. So my C will be now 3. But what is the prime number meaning? Prime number will always divisible by 1 and the number itself. Okay, if we take 2 will be divisible only by 1 and 2. If we take 5 will be divisible by only 1 and 5. So, but we take 4 will be divisible by 1, 2 and 4. So, there are 3, no? So, I will always take C and I will increment, and after this loop, if my C is equal to 2, then I will print that I. So if it is not equal to 2, then I will not print that. So this is also a very good algorithm, but similarly this time complexity is of n square, and if there are more numbers, for suppose uh, if I gave 49 for suppose, then this 49 or else I will take something like 30, like 37. Okay, I think 37 is a prime number. So if my I is 37, so it is prime number, means we can say it will divisible by only 1 and 37. But what these programs do, this program will runs j is equal to 1, j is equal to 2, up to j is equal to 37. But this will be only 1 and 37. So we are unnecessarily running this loop. So this may cause time limit exceeded problem also. So that is the reason the sieve of Eratosthenes comes into the picture. So we have many algorithms for finding the prime number. So we will run this one up to root n. I mean that is something other algorithm. So if you want to check that algorithm, you can see in Geeks for Geeks. Okay, so that algorithm is also, I mean, it some reduces to some extent, but it is also not that much of optimized one. So that is the reason the sieve of Eratosthenes, I mean, that comes into the picture. So what is that we can discuss now. Okay, so let's start the main algorithm now, sieve of Eratosthenes. So what we will do is, for suppose let's take this n as 10. What I will do is, I will take all the numbers. I will take all the numbers. And what I will do is, I will start from 2. I will start from 2, and what are the multiples of 2? I will cross them out. Okay. And again, I will go to the next one. If it is not cutted, sorry, not cutted, cutted is not the past tense, cut. So if it is not cut, then I will go to the next one. 3 is not cut here. So I will cross the multiples of 3 now. So 6 is already crossed. I will cross 9. And again, so I will not go to here because 4 is already cancelled. So now I will go to 5. Now I will cancel the multiples of 5. So already 10 is cancelled now. And again I will go to 6, but 6 is already cancelled. Now I will go to 7. I will cancel the multiples of 7, but multiples of 7 are not there. So I will stop here. Okay. And again go to here like that. I will do up to the last cancel one. So I came to 7, no? 7 multiples are not there, I will stop here. So what, I will start loop from 2 only, because this 1 is not the, I mean, neither prime nor composite. No, I will start from 2, and which is not cancelled, then these are my prime numbers. See, 2, 3, 5, 7. Is it true? Yes. So let's take some other example. Okay, so let's start the algorithm now. So what is the first step? We will always start from the 2. We will always start from the 2, and we will cross the multiples of 2. Okay, I'm crossing the multiples of 2 now. Okay. So, and now I will go to the next one. If it is not cancelled, 3 is not cancelled, so I will cross the multiples of 3. 6 is already cancelled. Next 15. So that's it. And I will not go to 4 because 4 is already cancelled. I will go to 5. So multiples of 5 are already cancelled. So this is not possible. 7 multiples of 7 are cancelled, and again 11. 11 multiples not there. 13 multiples not there. 17 multiples not there. And 19 multiples not there. So that's it. What is the remaining ones? We will start from 2 now. 2 we got 3, 5, 7, 11, 13, 17, 19. So that's it. So what we always doing it, we are cancelling the multiples. So if we cancel the multiples, we will left with only the prime numbers, no? So I think this is very, very easy, and I like this algorithm very much because we can easily find out the prime numbers up to the given n. If n is how much large, so it takes very less time because we are always cancelling the multiples of that particular number. Okay, so this is about the Seive of Eratosthenes. So let's get started, and I will provide the coding platform link in the description, so you can also go through that and you can practice. Okay, so let's start. Okay, so let's start coding now. So I want to return the array list now, so that I will take some array list. So I am assuming that you all know about the collections in Java. If you don't know, I recommend you to go through that collections also. Parallelly watch these videos so that you will be understand very well. Okay. So I took a array list. Now what I'm doing is I'm taking a boolean array. So what I explained in the beginning of this video, so cancelling. So this cancelling is nothing but that cancelling once I will make them as false. Okay, so cancellation, not cancellation is not possible in this programming, no? So that I'm taking it as true and false, so that it will be easy. Okay, let's take boolean prime and new boolean and plus 1. Okay, then what I'm doing is I'm inserting all trues. I'm assuming that everyone is true, means everyone is not cancelled. Okay, int I is equal to 0 and I less than n plus 1. Okay, and I plus plus. So why I'm taking here up to n plus 1 means, so there may be chance that given n also the prime number, no? So that is the reason I'm taking up to n. So to take up to n, I want to take n plus 1 elements. Okay. Now I'm inserting every element with true. Okay. Initially I'm taking p as 2 because from 2 only, no, I'm getting cancellation, and I'm checking if my p into p. P into p means I'm checking if it's something like how I'm checking is if its square is present in the array or not. If it is present, okay, we can continue. But if it is not present, there is no, I mean, there is no chance of cancellation. No, so why we are going through the array? So don't worry about that. I will explain that why I wrote here p into p. Okay, now I will check if my prime of p is equal to true. Okay, so if it is only true, then only cancellation occurs. No. Now what I will do is for int I is equal to p into 2 from its multiples from p into 2, and I less than or equal to something like less than or equal to n, and I plus is equal to p steps. It is going p steps. Means multiples of p means like we are going through p steps. Okay. Then I'm making them as like prime of I will be false now. Okay. So at last I will increment my p. Okay. Now at last what I will do is again I will traverse through the array from int I is equal to 2. From 2 only I will traverse the array and I less than or equal to n and I plus plus. What I will do is if my prime of I is equal to true, then only I will insert that particular I into my array list. A dot add of I. Okay, then at last I will return my AL. I think you have understood, but I will do the writing of this code. Okay, don't worry about that all the things. Okay, so let's check if it is working or not. Yes, it is working. Up to 10 we have only 2, 3, 5, 7. No, so let's submit. Yes, it is correct answer. Okay, so let's analyze the code. Okay, so let's get started. So I took n as 15. Now I take a boolean array from 0 to 15. Okay, so because I took here n plus 1, n plus 1 means n, that is up to 0 to 15. Now I inserted all truths. So capital T indicates true. Now what I'm doing, so come to this line, in p is equal to 2. I starts from 2. Then I'm checking if 2 into 2 is less than or equal to n or not. Yes, 4 is less than or equal to n. So that what will happen is, so that there is something else which we can cancel. Okay, you can understand this line very well after that. And I'm checking if my prime of p is equal to 2. So if it is equal to 2 only, then only no, I can cancel its multiples. So yes, it is true. Then for I is equal to p into 2 means p into 2 means its second multiple, that is 2 into 2, 4. From 4 onwards, every step of p I am cancelling. So cancellation means here nothing but I am making it as false. So I will take some other color. Okay. So what I am doing is for 4, 6, 8, 10, 12, 14, I am making them as false. Okay. Okay. Now it is over. Then I will increment my p. So initially my p is 2. No? Now I will be incremented this p to p plus 1, that is 3. Now I will start from 3 and I will check if my 3 into 3, that is 9, is there in this or not. I mean 9 is less than or equal to 15 or not. Yes. So what I will do, I will again check if it is true or false. Yes, it is true, so that I can cancel its multiples. So what are its multiples? 9 and 12 is already cancelled now, and 15. Okay, now I will make them as false. And again I will increment my p to 4. Then I will check, is my 4 into 4 is less than 16 or not? I mean less than or equal to 15 or not? It is not less than or equal to 50, so that I can stop here. See, only for 2 into this, how many iterations? Let's say 2 into some iterations, we are completing our total thing, and we are able to find out the prime numbers. So that's the power of this algorithm. Okay, so here it stops because 4 into 4 is not lies in this. 5 into 5 also not lies in this array. No? And we are also getting, so what are true here? So we will traverse from this. What are true here? From I is equal to 2, I less than or equal to n I plus plus. What are true? 2 is true, 3 is true, and 5, 7, 11, 30. So is these are right numbers? Is these are prime numbers? Less than or equal to 15? Yes. So okay, and you will get another doubt like, so we are always considering from 2, so why you are always taking 0 and 1 here? Because see here I'm inserting I. So if I starts from 2, so this I value will something like, so for suppose if this is the array, then I want exactly the second element, no? Second element, third element, I'm considering like that. So I should also include the zeros and ones. Okay, so that's it about this algorithm. So okay friends, thank you for watching this video. The coming up video is introduction to 2D arrays. So we are getting into the 2D arrays. So that's it about this video, and subscribe to my channel Quick Coder to get notified for the further videos. Thank you for watching.